Units are so important in chemistry. I've seen so many students either write their units wrong or completely forget to write their units at all. These simple mistakes can really add up on an exam and can even be the deciding factor of whether you pass or fail. So please know this. We'll start with going over our 6 main exponent rules. Note, whenever I say the word base, I am referring to a specific letter or unit. The first exponent rule is whenever our bases are the same and are being multiplied, we add the exponents together to get our new answer. The second rule is whenever our bases are the same and are being divided, we subtract the exponents together to get our new answer. The third rule is whenever anything is raised to another power or exponent, then we will multiply the exponents together to get our new answer. The fourth rule is whenever anything is raised to the power of 0, it will equal 1. The fifth rule is whenever anything is raised to a negative exponent, the variable changes its position and the exponent becomes positive. Negative exponents in the numerator get moved to the denominator and become positive, while negative exponents in the denominator get moved to the numerator and become positive. The sixth rule is whenever anything is raised to an exponent that is a fraction, this is actually a root. The numerator tells us what power the variable is raised to, and the denominator tells us what type of root it is. In both Chemistry 1 and Chemistry 2, you will need to know how to find, cancel out, and convert units. Let's start with some Chemistry 1 examples. The first example comes from a topic called dimensional analysis, which is just a fancy way to say unit conversion. Note, for this video, we will only focus on the units, but in the next video, we will go into more detail on how to set up these questions. We are asked to convert these units of inches squared to feet squared, and we are given a conversion factor that allows us to convert our units from feet to inches. We will start with the given 3.28 inches squared and multiply by the given conversion factor. Notice that the inches are not the same. In order to cancel the inches squared to get our desired unit of feet squared, we need to square the entire conversion factor. Rule 3 of our exponent rules now applies. Let's start applying this rule to the numerator. The 1 would be squared. 1 times 1 is just 1. The feet originally have an exponent of 1, which is not shown. We would multiply these exponents together to get 2. Do the same thing for the denominator. 12 would be squared. 12 times 12 is 144, and the inches originally have an exponent of 1, which is again not shown. We would multiply these exponents together to get 2. Now that we have the same units across from each other, we can cancel them out to get our desired unit of feet squared. We would multiply straight across and divide by 144 to get this long answer, but we have to round to the lowest amount of significant figures since those are the rules for multiplying. So we will round up to 0.0228. Here's another example of dimensional analysis. This time we are asked to go from cubic meters to cubic centimeters. Our conversion factor that allows us to go to this is given. We will align the units across from each other so they can cancel. The meters need to be the same in order for them to cancel out, so we need to raise this entire conversion factor by a power of 3. Rule 3 of our exponent rules now applies. Let's start applying this rule to the numerator. The 1 would be cubed. 1 times 1 times 1 is just 1, and the centimeters originally have an exponent of 1, which is not shown. We would multiply these exponents together to get 3. Do the same thing for the denominator. Since 10 has an exponent, we will multiply these exponents together to get -6. We do not have to do anything else to the 10. Looking at the meters, it originally had an exponent of 1, which is again not shown. We would multiply these exponents together to get 3. Cancel out the cubic meters, and we now have our desired unit. This would be our answer rounded to the least number of sig figs. Let's increase the difficulty just a little bit. This next example is part of the electromagnetic spectrum, specifically de Broglie's equation. In this equation, we would have to plug everything given into our formula. This equation requires us to convert units, then cancel. We will start with converting our joules to this new unit. We will replace the joules with the new unit and leave all other units the same. To make this easier, let's only focus on the units and not the coefficients. Starting with the numerator, let's see what we can cancel or combine. We are multiplying by fractions. The s has a denominator of 1. Multiply straight across, and we now have one fraction to work with. Rule 2 of our exponent rules applies here. Since we have the same base, which is s, and these bases are being divided, we must subtract the exponents. The s has an exponent of 1, so we are subtracting 1 minus 2 to give us negative 1. Rule 5 of our exponent rules applies here, where negative exponents change their position and become positive, so this means the s is actually in the denominator and now has a positive exponent of 1. We could have also just canceled out one s from the denominator to get this as our new numerator. Now that we have our numerator, let's combine what we can on the denominator. We can place a 1 for the denominator here and multiply straight across to get this as our new denominator for the overall fraction. We are dividing fractions now, so we will separate this into two separate fractions. Remember that when dividing fractions, we are actually multiplying by the reciprocal of the second fraction. Multiply straight across to get this. We can cancel out the kilograms and seconds. We can also subtract the meters to leave us with the final unit of just meter. The best way to avoid making mistakes is by practicing and preparing yourself for what you will see in this class. And you know I've made this easy for you by putting all the practice problems in one place. Simply go to melissa.help/practice, try the questions out, then come back to watch the next video.